Hello everyone, welcome back. Today we'll be talking about rate of change using differentiation. In this video, we'll break down key rate of change questions step by steps and how to understand and how to apply the concepts in exams. Okay, so over here on the left hand side, I have actually written down a simplification of it. Whenever you see the words rate of change of whatever it is over here, it is always representing dy dt in this instance. So there might be questions that say rate of change of volume. That would mean that it is the dv over dt. Whenever they say rate of change, is always that dx over dt, right? And then in some instances, for you to form the equation like this, okay, you're going to need to invert instead of finding dy dx, you're supposed to find dx over dy. Just remember that dx over dy is actually the reciprocal of dy over dx, which we will see some examples for later on. Now, in this general topic, you are always required to form an equation of some sort like so. So, for example, in a question, they could be asking you to find the rate of change of y. Then, in the question itself, they will always give you a clue on how to solve it. There will be always something that is given, and then something else that must be deduced by yourself. All right. Without further ado, let's have a look at some of the questions over here. So for your first question, it is given that y is equals to ln 2x squared plus 1 over x plus 2. Find the dy dx, and then subsequently, they will ask you to find the rate of change. Okay, now let's do the first part here. Finding dy dx for this equation, this is actually our quotient rule. So differentiate top, you have 4x over over 2x squared plus 1. Okay, then copy bottom, so you have x plus 2 minus the differentiation of bottom, which is just 1. Copy the top, ln 2x squared plus 1, the whole thing over the bottom square, which is x plus 2 squared, right? Then this is your dy dx equation. Now, if they never ask you to give a specific format, you are good to go with just this as your answer. Okay? Now, using this part here, when x is equals to 1, the rate of change in y is 3 units per second. Find the corresponding rate of change in x. What I would do in these questions is I would always actually write down the details given to me in the question on the right-hand side of the paper. So when they say x is equals to 1, I'm just going to simplify it and write it down on the side. The rate of change of y is 3 units. So this is rate of change of y, which is in other words dy over dt. This is equals to 3. Find the corresponding rate of change in x. So what we're looking for is we're looking for dx over dt, right? This is the question. Now, the next thing we're going to have to do is we're going to have to form the equation like I mentioned here with the givens and the deduced. So in here, the question is to find dx over dt. Finding dx dt, you're going to need to use whatever you've been given here, dy over dt. Sometimes it might be that you have to invert it, right? But in this case here, dy over dt multiplied by dx over dy. Right? Dx over dy. So dx over dy, like I mentioned earlier, is the reciprocal of dy over dx. Then now we're going to have to find dy dx first. So dy dx is already what we have up here, 4x blah 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 blah. Then what we're going to do is we're just going to make it very clear for the examiner. When x is equals to 1, right? Because x is equals to 1, then dy dx is actually, looking back at the top part here, you have 4 over 2 plus 1 is 3, then multiplied by 3 minus ln of 2 plus 1, that's 3, over 1 plus 2, which is 3 square. Simplifying the whole thing, you would have gotten 4 minus ln 3 over 9. This is DYDX, which therefore, sorry, which therefore means that dx over dy is actually the 1 over of this, which is in other words, 9 over 4 minus ln 3, right? This is your dx dy. Then finally, to find your dx dt, dx over dt is actually dy dt given here, 3 multiplied by dx dy, which is 9 over 4 minus ln 3, okay? Which will finally give you an equation of 27 over 4 minus ln 3. Type this into your calculator, you would have gotten 9.31. Okay? So, like I said, form your equation, use the data, you use the information given to you, and then from there slowly solve the equation, right? Next example. Find the volume V of a sphere of a radius r is given by V equals to 4 over 3 pi r cubed. The volume of the sphere is increasing at a rate of 24 cubic centimeters per second. So when you see centimeters per second, right, this is again rate of change. Then find the rate of increase of the radius when the radius is 6. Now, what I'm going to do is I'm going to write down everything, identifying that this is the volume units, then this is actually dV over dt, which is equals to 24, right? Then find the rate of increase of the radius, rate of change of radius, which in this case here is going to be dr over dt. This is the question, right? When the radius is equals to 6, when the radius is equals to 6. So now let's form our equation, right? What I'm looking for is dr over dt. Then it is always going to multiply something that I'm given, so equals to dv over dt multiplied by what? You need dr on top, and you need to get rid of the dv over here. So again, this is the reciprocal of dv over dr, right? Then next, we can move on to find the differentiation of volume in terms of radius. dv over dr is actually equals to, differentiate this, you will get 4 pi r squared, right? Then make it very clear again, when r is equals to 6, then 6 times this, you have dv over dr is 4 pi 6 square, which gives me 144 pi. Therefore, in other words, dr over dv is 1 over 144 pi, right? Then lastly, all we have to do is just solve the rest of the equation. dr over dt is actually equals to dv dt, given here, 24, multiplied by dr dv, which we have deduced here, 1 over 144 pi. Simplifying this, typing this into the calculator, you would have gotten 1 over 6 pi, which ultimately equals to 0.0531, 3 significant figures, right? Very straightforward, very simple. All you have to do is just follow the steps given here, then you'll be able to do this topic without any problems. Okay, next question over here. Variables x and y are related by the equation y is equals to 2 plus tangent 1 minus x. This is a trivial question where x is between 0 and pi over 2. Given that x is increasing at a rate of 0.04 radians per second, x is increasing at a rate. So per second, once again, is dx over dt. Find the corresponding rate of change of y when y equals to 3. So again, write down everything. rate of change of 0.04 per second, right? dx over dt is 0.04. Find the corresponding rate of change of y. You're looking for dy over dt. This is the question when y is equals to 3. Now, sometimes in this question here, they'll give you when y is equals to 3, but you will soon realize that you can't do much with this other than finding out what the x value will be here. Usually, you would have to find the x value if they've given you the y, right? So, again, now to start with the working, when y is equals to 3, right? 3 is equals to 2 plus the tangent of 1 minus x. Then bring the 2 over, tangent 1 minus x is equals to 1. Invert tangent 1, you would have gotten pi over 4. Therefore, from here, 1 minus x is equals to pi over 4, and x will simply equals to 1 minus pi over 4. Now, once again, I remind you guys that before we reach the final answer, I want my values to be as exact as possible. Okay? So now I have this extra information here already. I know that x is equals to 1 minus pi over 4. Then I'm going to try to continue with the rest of the question here. To find dy over dt, you will have to use dx over dt multiplied by dy over dx, right? dx over dt is the given, yeah. So to find dydx, now we're going to differentiate this. dydx is equals to differentiate to nothing, differentiate tangent, you have secant square 1 minus x, then you differentiate the inside, you have negative 1. Okay? Is equals to 1 minus pi over 4. Substitute this into this value here. dy over dx is negative of 1. Now, you can't type secant square into your calculator, guys. So what you're going to have to do is you're going to have to convert it to 1 over cos of 1 minus 1 plus pi over 4, right? Then this whole value here, you have to type square. So this is the sequence that you have to type in your calculator, guys. Cos of pi over 4, the answer, square that value, 1 divided by this value over here, and then times it with negative 1. If you type everything correctly into the calculator, you're supposed to get negative 2. Okay. Then from here, what we're going to do is we're going to solve the equation now. dy dt is actually equals to dx dt 0.04 multiplied by negative 2, which is your dy dx. And finally, this is equals to negative 0.08. Okay.